Welcome back to the deep dive. Today we're looking at something that usually sits at the very bottom of the fun things to do list.
Oh, yeah.
Somewhere between writing documentation and, I don't know, debugging legacy code. We are talking about AWS Access Management.
It's the vegetables of the cloud world, isn't it? Everyone knows they need to eat them, but nobody really wants to sit down and chew on them.
Exactly.
Yeah.
But we have a stack of source material here, specifically a deep technical breakdown, the Practitioner Level 203 guide. And it paints a very different picture.
It does.
This isn't just about compliance checklists. I want to frame this as, well, the architecture of trust. It's about building a digital fortress. It's about defining exactly who holds the keys to your kingdom and, maybe more importantly, who absolutely does not.
And the stakes, honestly, they couldn't be higher. We aren't just talking about preventing hackers here. We are talking about preventing disaster.
One wrong click.
One wrong click, one overprivileged intern, and your entire production database could just vanish.
That's the mission for this deep dive. We're going to decode the principle of least privilege. We're going to figure out how to stop the dreaded root account from becoming a liability.
A huge liability.
And we're going to look at the actual machinery of how AWS handles identity. So if you've ever worried about someone accidentally deleting your entire business, this is for you.
It's really a balancing act. On one side, you have security locking everything down so tight nobody can move.
Right.
On the other side, usability actually letting people do their jobs. Our goal is to find that sweet spot where you're safe, but you aren't, paralyzed.
Yeah, so let's start with that golden rule I mentioned, the principle of least privilege. It sounds very noble, doesn't it?
It does.
Like something from a medieval legal text.
It does sound formal, but the concept is actually very, very modern and pragmatic. Simply put, a user, an application, or a service should have only the permissions essential to do their specific job.
Nothing more.
Not a single permission more.
Right. So, using a real-world analogy, if I hire a plumber to fix the sink, I unlock the front door and maybe the kitchen.
Right.
I don't give them the combination to my wall safe or the keys to my car.
Precisely. And in the cloud, people violate this rule constantly out of convenience. You've probably seen it.
Oh, all the time.
A developer needs to read a file from an S3 bucket, but the permission setup is tricky, so an admin just gets frustrated and grants S3 full access.
Right, just to get it working. The famous last words of IT.
Exactly. I'll fix it later. But they never do.
Yeah.
And now that developer has the power to delete every single bucket in the account, not just read one file.
This brings up a key insight from the source material. We usually think of this principle as a shield against malicious hackers. Preventing the bad guys from getting in and wreaking havoc.
That is the blast radius concept. If a hacker compromises that plumber's account, you want to make sure they can only access the sink, not the safe. But the source material highlights something equally dangerous.
Which is?
Which I think people overlook. Human error.
Protecting us from ourselves.
Think about it. If you can't touch the big red button, you can't accidentally lean on it while you're reaching for your coffee.
Okay, good point.
If a developer only has read access, they physically cannot run a delete script on production, no matter how tired or distracted they are. Permission policies aren't just security walls, they are guardrails.
Guardrails against mistakes. So how does AWS actually enforce this? Because it's not just a toggle switch that says be safe.
No, it's done through permission policies. These are JSON documents, basically text files of code, that define specifically which API calls a user is allowed to make.
And it requires maintenance.
Oh, absolutely. Here's the kicker. You can't just set it and forget it.
And that's the access review part the guide mentions.
Right. People change jobs, projects end, interns leave. If you don't prune those permissions back, you end up with permission creep. Accuracy over time is what keeps the environment secure.
Okay, let's talk about the ultimate permission. The God mode of AWS, the root account.
The root account. The single most critical and dangerous identity in your entire environment.
The breakdown we're looking at lists some pretty intense powers that are exclusive to this account. It says only root can do things like modify support plans.
Yeah. Close the account entirely.
Or manage consolidated billing.
It goes even further. Root can restore IAM permissions. So imagine you accidentally lock every single administrator out of the system.
Oh, wow.
Root is the only one who can break the glass and let you back in. It can also delete specific bucket policies that restrict everyone else. It essentially transcends the standard rules.
It sounds like the nuclear launch codes. You want them to exist, but you don't want to carry them around in your pocket while you go grocery shopping.
That is the perfect analogy. The biggest takeaway here is do not use the root account for daily tasks. Do not use it to spin up a server.
Don't use it to create users.
Don't use it for anything routine.
So lock it away.
Deep storage. The security protocols here are non-negotiable. You need a very strong, complex password. You absolutely must enable MFA multi-factor authentication.
Of course.
And here's a crucial rule mentioned in the text. Do not share the root credentials.
Which seems obvious, but I bet in the early days of a startup, it happens all the time.
Groups are exactly what they sound like. Collections of users based on their function. So you might have a developers group, a finance group, or an admins group.
And policies are the rule books.
Yes. And the scale here is immense. The source notes there are over 1,580 distinct policies available out of the box.
Wow.
And the logic they use is important. It's an allow list model.
Meaning the default answer is no?
Correct. In AWS, there is no need for an explicit deny. If an action isn't explicitly written down as allowed, it is automatically denied. You have to actively grant permission for anything to happen.
I noticed the text mentions inheritance regarding groups. Is that just a convenience thing?
It's a scalability thing. Imagine you have 50 developers. If you assign permissions to each of them individually, and then a policy changes.
You have to update 50 users.
One by one, it's a nightmare. And a recipe for error, you'll miss one.
Guaranteed.
Exactly. Instead, you assign the policy to the developers group. When you hire a new person, you just drop them in the group and they inherit the permissions. When they leave, you take them out. It's cleaner, safer.
And keeps you sane.
It keeps you sane. Plus, there's a hard limit. You can only apply 10 policies directly to a user. Groups let you bypass that friction.
Now, here is where it gets really interesting for me. The distinction between a user and a role.
Okay.
Because in normal life, a role is just a part you play. But in AWS, it's a specific technical thing.
This is a fundamental concept to grasp. A user typically has long-term credentials, a password or access keys that stay with them.
Right, they're persistent.
A role is different. A role has permissions, but no permanent identity associated with it.
So if a user is an ID badge, what is a role?
Think of a role like a high-security vest hanging in a locker. A user or even a machine like an EC2 server can put on that vest for a temporary period. When they assume the role, they get the permissions that come with the vest, but when they take it off or when the time limit expires, those permissions are gone.
And the source emphasizes that roles are about temporary authority.
Exactly. And that temporary nature is a huge security advantage. It means there are no long-term passwords floating around that can be stolen and used months later. If a hacker intercepts the session token from a role, it's useless an hour later.
This focus on planning versus maintenance leads us into two legal-sounding terms the source uses: due diligence and due care.
It's legal terminology applied to tech. Due diligence is the planning phase. It's the thought you put in before you assign access.
And AWS has a specific tool for that, right? The policy simulator.
The policy simulator. It's incredibly useful. It lets you test drive permissions. You can say, if I give this policy to this user, can they delete this bucket?
And it tells you.
And the simulator will tell you yes or no before you actually apply it to the live environment.
That prevents the oops moments we talked about earlier.
Exactly. And for due care, the ongoing stuff, there is the access analyzer. This uses machine learning to scan your account and look for weaknesses.
What kind of weaknesses?
It might say, hey, you have a bucket here that is open to the public. Did you mean to do that?
It's like having a security consultant constantly looking over your shoulder.
Which, given the complexity of these policies, remember, over 1,500 of them, is exactly what you need.
Okay, let's shift gears to one of the scariest parts of cloud security. Secrets. We're talking passwords, API keys, database credentials.
The keys to the kingdom?
The source mentions a concept called separation of duties. It says it's rare for users to have both console access and programmatic access. What does that mean?
Console access is being able to log into the website, the visual dashboard. Programmatic access is having API keys that let you run code commands.
And they should be separate.
Usually, a human being needs the website, and a piece of software needs the API keys. It's rare that one entity needs both. If you give a human API keys, they might write them down or save them somewhere insecure.
Which brings us to the big don't. The cardinal sin of cloud development.
Never, ever, ever store secrets in your code. Do not push passwords to GitHub. Do not hard code them into your application.
Don't put them in your container registry.
Never, because if that code leaks, or if someone just inspects the open source repo, they have your passwords.
And it happens constantly.
Bots are scanning GitHub every second looking for AWS keys. If you push a key, it's compromised in seconds.
So if we can't put the password in the code, where do we put it?
AWS provides two main vaults for this. First, the Systems Manager Parameter Store. This is great for managing configuration data strings, license codes, standard passwords.
And they're encrypted.
You can encrypt them using KMS keys. It's straightforward and effective.
And the second one?
The AWS Secrets Manager. This is the heavy hitter. It's specialized for database credentials like for RDS or Redshift and other sensitive things like OAuth tokens.
That has a killer feature, right?
Rotation. This is huge. The Secrets Manager can automatically rotate, meaning change the passwords for you. So let's say you set it to rotate every 30 days.
How does that work?
The Secrets Manager talks to the database, changes the password there, and then updates the secret in the vault. Your application just asks the vault for the current password.
That is incredibly smart. It removes the human element of, oh, I forgot to change the password this month.
Precisely. It turns a static secret into a moving target. Even if a password was stolen, it might be invalid an hour later because the system changed it automatically.
Now, we touched on this with the root account, but the source lists it as a second line of defense for everyone. MFA, multi-factor authentication.
Non-negotiable. If you have a password, you must have a second factor.
The technology here has evolved, hasn't it? The source mentions FIDO standards.
FIDO stands for Fast Identity Online. It's a set of global standards designed to eventually eliminate passwords entirely by using cryptographic keys.
And for now, in the MFA world, what are the options?
We see a few types. First, you have passkeys, which are becoming really popular.
Right, these sync across your devices.
Think Google Password Manager, 1Password, or even your fingerprint or Face ID.
Then the classic virtual authenticator apps.
Using TOTP time-based one-time passwords. Apps like Twilio Authy, Duo, Microsoft, Google. The source notes that these are supported even in the US GovCloud regions.
And finally, for the hardcore security needs, hardware tokens.
Physical devices you carry. The source specifically mentions Thales tokens for general AWS use and HyperSecure tokens, which are exclusive for US GovCloud IAM users.
So air-gapped.
These are for when you want zero chance of a digital intercept because the key is physically separate.
It's reassuring to know those options exist. Now, as organizations grow, they don't just have one AWS account. They might have dozens or hundreds. How do we manage access across that sprawl without going crazy?
This is where we step up to the IAM Identity Center, formerly known as Amazon SSO.
The single sign-on solution.
Exactly. Instead of creating a new user John Doe in every single one of your 50 AWS accounts,
Which is a nightmare.
you create John Doe once in the Identity Center. Or even better, you connect the Identity Center to your existing corporate directory like Active Directory, Azure AD, or Okta.
So John logs in with his normal company email, and boom, he has access to all the AWS accounts he's allowed to touch.
Yes. And under the hood, this uses a zero-trust approach. Remember how we talked about roles being temporary? The Identity Center relies on time-based access tokens.
So no permanent passwords.
Unlike the standard IAM user who has a permanent password, Identity Center issues short-lived tokens.
It feels like the whole industry is moving toward temporary being the standard for security.
It is. The less time a credential is valid, the safer you are.
There's one last scenario I want to cover, which is the cross-account situation. Let's say Team A has a bucket of data in account 1, and Team B has a user in account 2 who needs to read that data.
Ah, the handshake.
How do they shake hands?
This is a classic exam question and a real-world headache. The wrong way to do it is to create a duplicate user for Team B inside account 1.
Right, because now you have 2 users to manage and 2 passwords to lose.
Exactly. The right way is to use a cross-account role.
Walk us through that handshake.
Okay. Account 1, the trusting account, which holds the bucket, creates a role. This role has a policy that says, I allow access to this bucket.
Yeah.
It also has a trust policy that says, I trust account 2.
Okay, so the door's unlocked, but only for account 2.
Right. Then the user in account 2, the trusted account, calls upon the STS, the Security Token Service. They say, I would like to assume that role in account 1.
And it lets them in.
Because the trust is established, STS grants them temporary credentials. They virtually teleport into account 1, do what they need to do, and then the session ends.
That is so much cleaner than sharing passwords or creating duplicate users.
It keeps the boundaries clear, and it connects back to those policy types we saw in the notes. You have identity-based policies attached to the user and resource-based policies attached directly to the bucket.
And in cross-account access, you're using both.
You're often dealing with both, yes.
Okay, let's unpack this. Or rather, let's wrap this up. We've covered a lot of ground.
We have.
We started with the dangers of the root, off that thing down. We moved to the granular control of IAM policies. Remember, there are over 1,500 of them.
Lot to choose from.
We talked about automating secret rotation so you don't have to remember to change passwords, and the absolute necessity of MFA.
And if I had to summarize the mission we started with, it's that access management isn't a one-time setup task. It's a lifestyle.
A lifestyle, I like that.
It requires due care. You have to use tools like Access Analyzer to constantly monitor what is happening. The cloud is dynamic. Your security needs to be dynamic too.
It really creates a picture of a living, breathing organism rather than a static building.
That's a great way to put it.
And that leads me to a thought I've been mulling over since we discussed the Identity Center. The source keeps emphasizing zero trust and time-based tokens.
Yes.
We're moving away from permanent passwords and towards one-hour tokens or temporary roles.
We are. It's the direction the whole industry is taking.
So, here's my question for you and for everyone listening. If the future of security is purely temporary, time-limited access, does the concept of a permanent user eventually become obsolete? Are we heading toward a world where logging in doesn't mean opening a door, but just getting a visitor pass that dissolves in your pocket after an hour?
That is a fascinating implication. It certainly seems like identity is becoming less about who you are permanently and more about what you are authorized to do right at this second.
Context is replacing credentials.
Context is replacing credentials. Well said.
Something to think about the next time you type in your password or scan your fingerprint.
Indeed.
That's it for this deep dive into AWS Access Management. Check your password policies, turn on MFA, and we'll see you next time.
Stay secure, everyone.